What's going on, guys? Welcome back to Cosmic Reactions. I just want to apologize for the last video. I didn't realize the quality was so bad. I keep forgetting to turn my HDR off. It makes the quality look bad when I leave it on. But I turned it off this time. I got a new video. It's called Google's Quantum Chip. Did we just tap into parallel universes? This video is only 3 days old, and it is by NASA Space News. Alright guys, let's check it out.
Let's talk about Google's Willow chip, a quantum computer so powerful it's making scientists question reality itself. Willow didn't just break records, it shattered them. It solved a problem in under 5 minutes that would take the fastest supercomputers on Earth 10 septillion years to finish. And here's the twist. Some scientists think this quantum magic might...
Hold up. How are we smart enough to invent something like this, is what I'm saying. How can we invent something that can surpass us like that much? Did he say what? Not even, it was more than that. What is
the twist? Some scientists think this quantum magic might involve parallel universes, where calculations happen across multiple realities at the same time. In this video, we'll break it up. Calculations happen across multiple realities, computers on Earth 10 septillion years to finish.
10 septillion years. That's insane. I've never even heard of that number. So that could solve a problem that it would take our normal computers 10 septrillion years to complete. Now that's crazy.
And here's the twist. Some scientists think this quantum magic might involve parallel universes, where calculations happen across multiple realities at the same time. In this video, we'll break it all down. What Willow achieved, why the multiverse is suddenly part of the conversation, and why some experts remain skeptical. Google's Willow chip is a 105-qubit quantum processor. Now, if you're wondering why that's a big deal, let's start with the basics. Classical computers use bits, zeros and ones, to process information. Quantum computers, on the other hand, use qubits, which leverage two principles of quantum mechanics: superposition and entanglement. Superposition means qubits can exist as both 0 and 1 at the same time, while entanglement connects qubits so that changing one affects the others instantly, no matter how far apart they are. What does this mean? It means quantum computers can process an enormous number of possibilities simultaneously, something that classical computers simply can't do. And Willow's recent achievement takes this concept to a whole new level. Here's what happened. Willow was tasked with solving something called a random distribution benchmark. Essentially, it had to generate outputs based on extremely complex and entangled quantum patterns. Classical computers? Forget it. This task would take them 10 septillion years. That's a 1 with 25 zeros behind it.
25 zeros.
In under 5
That's
minutes.
Crazy.
This result isn't just about speed. It's about proving that quantum computers can tackle problems that classical computers find impossible. Scientists call this quantum supremacy, the point where a quantum system outperforms even the most advanced classical machines.
Now, my bad, but this just popped in my head. You know somebody's going to want to put this in some type of AI that can walk and talk around. I guarantee it's going to happen in the future. And if it's that powerful, man, it would destroy us. Just because of the way we destroy things, it would want a perfect society. That's crazy, man. That is scary even. Like, I don't even see how we can make something like that.
Google first claimed quantum supremacy back in 2019 with a 50-qubit chip. That chip solved a problem in 200 seconds, which they said would take classical systems 10,000 years. IBM later challenged that claim, saying a classical computer could do it in days. This time, Willow's leap to 105 qubits makes its achievement exponentially more powerful. Every additional qubit doubles the processing power, so Willow isn't just twice as good, It's orders of magnitude ahead of its predecessor. And there's more. Willow incorporates cutting-edge error correction techniques to address one of quantum computing's biggest challenges: fragility. Quantum systems are incredibly sensitive. Tiny environmental changes can cause errors. Google's advancements in stabilizing Willow mean that quantum systems are becoming more reliable, and that's a critical step toward practical quantum computing. What does this all mean for the future? Well, right now, Willow's task was purely theoretical, but this kind of power could revolutionize fields like cryptography, drug discovery, and even climate modeling. It's a milestone, a glimpse of the possibilities that lie ahead.
But that's it.
Now, let's talk about what's really blowing people's minds: parallel universes. It sounds like something out of a Marvel movie, but the idea actually comes from serious physics, specifically a concept known as the multiverse hypothesis. Here's the deal. Quantum mechanics tells us that particles can exist in multiple states at once. This is superposition. But when we observe or measure them, they seem to collapse into a single state. That's how most physicists explain it. But David Deutsch, a pioneer of quantum theory, proposed something radically different. What if those other possibilities don't disappear? What if they exist in separate parallel universes? According to Deutsch's many worlds interpretation, every outcome of a quantum event happens, but in its own universe. For example, imagine flipping a coin. In our universe, it's heads, but in another universe, it's tails. Now scale that idea up to a quantum computer. When a quantum system performs a calculation, it explores multiple solutions simultaneously. The multiverse hypothesis suggests that this happens across different universes, with each universe handling part of the computation. And this is where Willow comes in. Its ability to solve a problem so complex, so quickly, makes some scientists wonder if it really is tapping into parallel worlds.
But why would they even think that without some type of proof? I mean, there would have to be a reason for them to think this thing was communicating with other universes. Like, they didn't... I wouldn't think they would just come off the top of their head and be like, hey, I wonder if this thing's communicating with other universes. Like, there has to be a reason they thought that to begin with. I hope he talks about that.
Imagine billions of versions of Willow working together across infinite universes, with the final answer popping up in our reality. Sounds insane? Maybe. But it's one way to explain quantum computing's almost magical speed. Of course, not everyone agrees. The Copenhagen interpretation, which is the most widely accepted view, argues that quantum states are just probabilities. When you measure a system, the wave function collapses into one state. No need for parallel universes. So, are quantum computers like Willow harnessing the power of the multiverse? Or are they just really good at manipulating probabilities? We don't know for sure, but the possibility that quantum computers could offer the first practical evidence of a multiverse is enough to keep the scientific community buzzing.
Your brain lights up like a TV when you're playing video games.
Guys.
So check this out. Researchers from the University of California...
I got it blocked.
As exciting as this all sounds, not everyone's on board. Scientists and skeptics have raised some valid concerns about Google's announcement, and it's worth digging into them. First, there's the issue of practical relevance. Willow's achievement involved solving a random distribution benchmark, which is a theoretical problem chosen to highlight quantum performance. Critics, like physicist Sabine Hossenfelder, argue that while this is impressive, it doesn't have any immediate real-world applications. It's like building the fastest race car, but only testing it on an empty track. Cool, but not exactly useful yet. Then there's the elephant in the room.
I'm surprised the government isn't drooling over
Willow
that thing.
has 105 qubits, which is a big deal. But practical quantum computing will require millions of qubits, and not just any qubits, but ones that can operate reliably without errors. Quantum systems are notoriously delicate. with even tiny disturbances causing computational errors. Google's advancements in error correction are promising, but we're still far from solving this challenge completely. So, does this mean Willow's achievement doesn't matter? Not at all. Quantum computing is a work in progress, and every milestone, even theoretical ones, brings us closer to a future where these machines could change the world. The skeptics aren't dismissing Willow. They're reminding us that there's still a long road ahead. When we get there, though, the possibilities are staggering. Faster drug...
Hold on, but if this chip is as advanced as they say, why couldn't it fix the problems and go through the steps for them, help them? It just said they still had steps to go, that there's a long process. They couldn't use the chip to get through these milestones? You know, if it could solve a problem that fast that it would take our normal computers however long to freaking solve it, they should be able to use that chip to go through these milestones and get to their end goal quickly. Not that I want that, but I'm just saying you would think that that's what they would be doing.
Road ahead. When we get there, though, the possibilities are staggering. Faster drug discovery, breakthroughs in materials science, ultra-secure encryption, and solutions to problems we can't even imagine yet. Willow is progress, and progress is worth celebrating.
Has to be a way they can use
Thank you for
that.
watching. If you enjoyed this mind-bending look at the future of technology, don't forget to like, share, and subscribe.
Alright guys, that was kind of short. If y'all don't care, I saw another video about this chip. But it was Joe Rogan. I almost started to react to that, but I figured this would be more factual. Since we checked this one out, I'll go back and we can watch the Joe Rogan one real quick. Let me go to my history right quick. Alright guys, this one's called Google's Quantum Computer is Communicating with Multiple Universes? ? Joe Rogan. But the maker of this video is JRE Moments. Excuse me. Alright, we'll check this out real quick. See what he's talking about.
Well, one of the things that I've talked to about with some pretty insanely brilliant people is quantum computing.
Oh, yes.
And this new Google quantum computer that can do essentially the way a quantum computer works, a problem that would take thousands of years for every computer on Earth to solve.
I've read that.
It can solve in a second.
Yeah.
Something that can take more years than you literally can understand. It could be solved in 15 minutes.
Yeah, I read that.
It's insane. And this is where it gets really weird. The way it was explained to me, and we should have to Google how quantum computers work and why people connect them to the multiverse so I don't fuck this up. But the idea is that they're pulling answers from different universes simultaneously. They don't even completely understand how this is working. But the amount of power in computing is incomprehensible.
Yeah.
Like you're only looking at it and there's numbers, you could write all those numbers out, but your brain's not capable of grasping really what's going on. Yeah. And it's probably the biggest breakthrough technologically in human history by a long stretch. And it's all...
That's what I don't understand. Like I was saying earlier, I don't understand how we can make something that's beyond our comprehension. Like, don't you have to be able to comprehend it when you're making it? Or are you just in the lab just trying something and, like, accidentally discovering things? I don't know how they find what they find or how they make what they make, but good grief, man. You would think we couldn't build something that we can't even understand at all. I don't know. That's just boggles my mind.
All happening without most people even being aware of what the implications are. So see if you can Google an explanation of how quantum computers work.
trying to.
Was it Mark Andreessen that was explaining to us that it's pulling from different universes?
No, that
Who was that?
being talked about in the wording of the Willow description.
Right.
But I also, just to add, when I was reading about this, they said that these benchmark numbers are coming off of Google's own data. Like they're the ones that set like the scale of what some of the quantum.
Are you
numbers
skeptical? Is that what you're saying?
I'm just
Are you calling bullshit on Google?
No, not at all. Not at
I
all.
feel
Not
like
at
he
all.
is.
No.
I
I'm
feel
just
like
a
you
grain
are.
of salt, like just to say that, like I think they used tillions is the
Yeah,
number or something like that.
septillion.
See, that no one even can grasp that.
Yeah.
That's just based, but that's a number based off of their formula too.
Right.
That's all.
Right. What is the definition of how it works? The way it pulls from multi.
I'd like to
universes?
know that
I think
myself.
I'm trying to find it, but I think the understanding I got from it was it's just too powerful to get from our universe alone. You'd have to have more than one, and I don't like. That's just
Like, what does that mean?
Yeah, what does that mean? I think he
Exactly.
just
What
made
does
that
mean?
up.
Right.
Understanding.
What is that thing that they have? And if you ever seen the chip itself is very small.
Yeah.
It's like the size of a saltine cracker.
Yeah.
And then this entire mechanism around it is just the insane amount of cooling. Okay. Google's quantum AI founder said the performance gains lends credence to the idea that we live in a multiverse. The idea is that Willow might be communicating with parallel universes
Might
to
be.
finish calculations faster. Like what does that mean? The announcement.
So that's the only way that we can comprehend that chip making calculations that fast. It's saying it's pulling from other dimensions to get the calculations that quickly because I don't know, because they don't understand how it's doing what it's doing. Maybe they built something thinking it would be one way and it turned out to be another, you know?
Led Google.
Like they made a beast and didn't even realize it was way more powerful than they thought it would be.
Google's already high stock price to surge, which isn't that shocking, but perhaps most surprising for us lay people that Google's quantum AI founder and lead, Harmut Nevin, said that the chip's performance lends credence to the notion that quantum computation occurs in many parallel universes in line with the idea that we live in a multiverse. And then it says, excuse me? This obviously has caused a bit of a stir and it isn't exactly clear on how he made that leap. It sounds a bit like something out of a sci-fi movie, and I'm definitely not going to pretend I'm an expert, but it's worth pointing out that Google is very much still in the theoretical research phase of this journey. This is very weird stuff. An evolving scientific field that even people working on it don't fully understand.
That's
2 hours later.
that makes no
Okay,
sense.
so this is what it is. One of the world's most advanced classical computers. Okay, here it is with this problem. So AI's founder and lead, Hartmut Nevin, said that the new chip had performed a purposefully complicated exercise called a random circuit sampling benchmark in 5 minutes. One of the world's most advanced classical supercomputers, on the other hand, it would take 10 and then 3 zeros, 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 3 zeros.
25 zeros.
Years to perform the same exercise. That's 10 septillion years, which exceeds known time scales in physics and vastly exceeds the age of the universe. So it can do more time than vastly exceeds the entire age of the universe, and it can do it in 5 minutes. And the reason it can
That's
achieve
crazy.
such a monumental improvement in calculating capacity is because Willow is made up of 105 qubits and can track the potential of each of those at once, allowing it to record potential data much faster and come to the right answer sooner. So, like, what is happening?
That's too much information.
What do you mean?
I get it, but I don't get it.
I don't get, how does that prove the multiverse or provide
That's what I don't
evidence that
understand.
the multiverse is real, like, and that it's getting it from parallel universes? Like, what
But
are we even saying
but
here?
it couldn't come up with those answers within the allotted time span. That's
Yeah. What?
fuck. I can't even explain. I mean, funnily enough, this is that my brother's into all of this stuff. Sean, he's
in simpler language.
He would probably be able to explain it to you, Sean.
Probably.
He's like
Well, he would
this
give it a
stuff.
shot.
He would, certainly.
I think he was the one that was probably explaining it to us. In simpler language, Willow is doing one calculation while an unknown number of Willows in other universes parallel to our own are doing their own calculations, and they are sharing that data to avoid needing to individually do every possible calculation to finish the equation. What the fuck does that mean? How are they sharing data between universes? I don't know. Ask Nevin. Remember, this is all theoretical and doesn't prove anything,
That's
but
wild.
Nevin is saying that the fact that the chip can outperform our best supercomputers by such a wide margin means that it might have broken Newton's theory of physics. Yo, what does it say under that, Jamie?
What does this mean for me?
Keep that going. Oh, put that back on. Scroll up a little bit.
It's right here.
Okay, this is what I wanted to look at. At this point, it's an exciting look at what computing might take one day, but it isn't something you're going to see in your next Pixel phone. Quantum chips need to be isolated in incredibly specific chambers. Yeah, this is the thing. It's cooler than, it has to be cool to a point where it's colder than outer space, sealed away from any possible signals such as microwaves, radiation, radio signals, etc., for fear of that noise leading to potential mistakes, and have specific signals delivered by purpose-built wires. Who figured this out?
Right.
Where are those eggheads?
How did somebody build
How did
this?
they even come up with that? If that
I don't
was
get
the
it.
case? I don't.
How did they
hurts
figure
my
out you have to
head.
do that? All of it.
That's just brain damage.
That's one of the most humbling things that I've found about doing this podcast is realizing how genuinely dumb we are in comparison to the amount of information that's available.
no question.
Today, we're checking out Once Human.
I hate
It's an
this.
open
I'm
world
sorry,
survival
guys.
game set in a supernatural post-apocalyptic.
Oh, that's it. Alright, guys. I appreciate y'all watching with me. I hope y'all enjoyed the video. I hope it was interesting. I hope y'all have a good night. I'll see y'all next time.